So thanks for coming out on a Thursday evening, and so let's get started. All right, look at that, the technology working all the way around. Okay, so here's the simple plan for this evening. Just a quick review of what's happened over the summer and into the fall here, as far as our weather and climate. Particular emphasis, of course, on what's going on in the oceans and the sea ice, and then perhaps what you really came for, the outlook for the winter. And this is kind of interesting because in addition to the traditional climate products that are available, a couple of new things to show you. Just in the last year, the National Weather Service, NOAA, has rolled out a seasonal sea ice prediction computer model system, and it's been around for about a year, so we don't know how good it is, but it's a new tool in our toolbox for things that are important in Western Alaska, like sea ice. And then also some of my work has been looking at, given the relationship that exists between sea surface temperatures and, of course, sea ice, can we use what we know is our extremely warm oceans to get a handle on what the upcoming sea ice season might be. So some new stuff here, some old stuff. As always, feel free to ask questions at any time. You too, Dan Joling online. Okay, summer 2019. This is a map showing the ocean surface temperature departure from normal in degrees Fahrenheit for May through September, so 5-month season. If the oceans around Alaska were all completely normal, the oceans would be all white. As you can see, there's not much white space there. Almost all of the Bering Sea, except for the far southwest, all of the Chukchi Sea, almost all of the Alaska portion of the Beaufort Sea, for the 5 months, well above normal. Gulf of Alaska, above normal as well. And some of these departures are really very remarkable. For a 5-month period, Kotzebue Sound averaging more than 8 degrees above normal. Same up by Utqiagvik. Notice even out in the open Chukchi Sea there, to the west-northwest of Utqiagvik, 7 to 8 degrees above normal for a 5-month period. That is absolutely amazing. Open ocean temperatures rarely vary by more than a few degrees from normal. And I should say normal here is over a 30-year historical period. This particular one based on 1971 to 2000. In Norton Sound, you can see generally 5 to 7 degrees above normal for the 5-month warm season. Really quite amazing. One interesting feature that's not hot here is that you'll notice there on the west side of the Bering Strait, there's an area it's still above normal, but not very much. That emerged in July. It was very warm earlier in the season, but that near normal waters have been persistent on the west side of the Bering Strait most of the time since July. Kind of interesting. If you've been to any of these that I've done, you know I like nothing better than these long time series plots. So here we have the northern Bering Sea, that's in the little green box there on the insert. So this is the average May through September temperature for basically the Pribilofs northward, and using the NOAA data set that goes back 150 years, I've plotted up the average May to September temperature here in that box since 1900. The colored dots are the 10 coolest and the 10 warmest. And obviously what jumps out at me there is that 6 of the last 6 years have been in the top 10 warmest of the past 120 years. This year, the warmest of record, just a little bit above 2016. But every year now is a top 10 year. Really very, very amazing. And there's only one top 10 year that was in the 20th century. The rest are all since 2000. we haven't had a coolest 10-year since 1971 as far as ocean temperatures May to September in the northern Bering Sea. Okay, so how does that was the plot for that whole region there for the northern Bering Sea. How does this look spatially? I used a different data set here, but because all of the warmest years are very recent, this will work just fine. And this particular data set includes the Chukchi and Beaufort Seas, which that other one does not. So little different data set, but the answers I'm sure would be the same. Most of the northern Bering, the warmest of record, that's the fire engine red color. This is the ranking of the June through September temperatures. Again, the ocean surface. Most of the Alaska portion of the Chukchi Sea and Beaufort Sea, also the warmest of record. Norton Sound was not the warmest of record. Most of Norton Sound from about Nome East, either last year or 2016, were by a fraction of a degree warmer than this year. The darkest orange, the pumpkin orange there would be the second warmest, and you can see there are none of the blue colors there, which would be cooler than normal. The sky blue there is an artifact of the plotting program here that blanks out the near coast. But if we had that, you'd see, even if we had that filled in, you'd see even more red and orange. So you've lived through an epic record setting, never before observed event. So so we've been looking at the ocean surface temperature. Of course, when it comes to sea ice and the ecology, the food web, it's not just what's going on at the surface, of course. We need to look into the water column. And so this is from NOAA's global ocean data assimilation system. And what this is the rank of the upper 300 feet of the ocean, the total heat content. So basically a measure of the upper 300 feet of the ocean's heat, temperature. And again, you can see the fire engine red, much of the southern Bering Sea, the warmest of record. Again, we have that landmass issue, but the northern Bering Sea, especially near the Alaska coast, the warmest of record. There is a little bit of cool showing up here. That's mostly an issue with the short period of record, but down south of the Aleutians a little bit. I don't think that little blue speck there in the Gulf of Antier is real. It could be, but I think that's probably an artifact of the analysis. So it's warm at the surface. That warmth penetrates to depth. And of course, probably everyone here is well aware the big impact of this water temperature at depth is what's happening at the bottom of the Bering Sea. This is a slide courtesy of Lyle Britt from NOAA, and he'll be here in a couple weeks, probably to talk much more in detail about the fisheries findings. This is the physical oceanography part. So this is a plot of the temperature at the bottom of the Bering Sea. And the color scales here are on your left-hand side there. And of course, your eye immediately goes to either the blue and purple. That's water at the bottom of the Bering Sea that is at or below 32 degrees Fahrenheit. The purple is actually below 29.5 degrees Fahrenheit, and that's very cold, very salty water. Historically, NOAA Fisheries did not do these surveys in the northern Bering Sea very often. They've done them every year for a long time in the southern Bering Sea, but not so much in the northern. So 2010, from the fisheries point of view, was a pretty typical year. So we're guessing that the bottom temperatures are normal. We can't show you a time series of that because we don't have it, but we think 2010 is something like the historical average. You can see basically all of the Bering Sea bottom water temperatures south of St. Lawrence Island all the way past St. Matthew, down past the Pribilofs, even into western Bristol Bay. Bottom temperatures were below 32 degrees. Not only cold, but salty. It's a very stable. This is way, this is not being affected by summer storms. This is very stable water. And that was the barrier that kept the northern Bering Sea like an Arctic-like marine system, whereas the southern Bering Sea, different kinds of species, different food web, really reflecting basically just an extension of the North Pacific. So 2010, historical normal. 2017, there's not as much blue and purple on there, but there's some, especially north of St. Matthew Island. But even in western Bristol Bay, there's still some cold water. There's none of that purple color, not the very coldest, very saltiest water, but some. And then, of course, 2017-18 was the first record low Bering Sea ice with the ice collapse, excuse me, in February that year. And there was hardly any ice all winter south, west of St. Lawrence Island. And the result being a complete collapse of that cold pool and a completely unexpected collapse. Nobody, near as I can tell, not one biologist, not one oceanographer ever thought we could see that kind of change in 1 year. And we all know summer of 2018, we see those southern Bering Sea fish moving north. We have birds dying and apparently a starvation. So big changes in that whole food web as that ice wasn't there to support that algae on the bottom of the ice and the very base of the food web, and that then, thank you. That of course then worked its way up the food web. 2018-19, you will remember well last winter. So last winter started off really terrible. It was the lowest November sea ice extent of record in the satellite era in the Bering Sea. But then we got colder weather in December and into early January, and the ice grew, but it was very thin. It only really started to get going in December, and then the storminess started up and completely obliterated that ice. So what NOAA found on their trawl survey this summer, there's a little bit of the cold pool has returned southwest of St. Lawrence Island there. Nothing like even 2017. And as Gabe pointed out, while there's some of that blue color, there's hardly any of that purple color. This looks encouraging, but actually that lack of that very coldest, very saltiest water is significant. And of course, that was nowhere near enough to keep the southern fish from, well, they probably overwintered, but obviously those Pacific cod and the walleye pollock, widespread, and again, widespread effects through the ecosystem. So this is the oceanography, but it big effects on people's lives and livelihood here in Western Alaska. All right, here's where we're at now. On the right-hand side is the National Weather Service's Sea Ice Program analysis from Sunday of the current ice extent. And you can see that there is no ice anywhere close. If you got it on Sunday, if you got in your boat at Utqiagvik and steamed due north, you'd go about 400 miles until you ran into ice on October 20th. The ice, so this was Sunday. Oh, well, it's probably grown a lot since then. Wrong. The Chukchi Sea has actually lost ice area this week. The Beaufort Sea is still growing, although very slowly, but it is growing. And you can see it looks completely different than last year when there was much more ice at this point in the Beaufort Sea, and there was more ice in the Chukchi, although it was pretty low. We thought 2017 mid-October was low, and it was. This year, way, way worse. Here's how bad it is. This is the combined ice extent for the Chukchi and Beaufort Seas. The green line is this year. This is updated through yesterday. The red line is the previous lowest at this point in the season, 2012. And you can see now we've crossed that and are now much, much lower sea ice than we've ever had in the satellite era for the Chukchi and Beaufort Sea. And that is likely, I would guess, to continue for weeks to come, given the forecast weather pattern. Of course, in the Bering Sea, except in some freshwater outlet areas and maybe in some very protected bays, there's no ice yet, and there isn't going to be any out in the open Bering Sea for quite a while. Just to update you, this is the average sea surface temperature departure for last week. Gulf of Alaska has cooled off, pretty much plus or minus 0. So that's good news for them. The Bering Sea is not as far above normal as it was, but there's still pretty much nothing but red in the Alaska portion of the Bering Sea. Notice that band there of 6 degrees above normal from south of Nome up past Wales into the Chukchi Sea. Southernmost Chukchi, the central and northern Chukchi remains on fire. That cooler, the near normal water continues on the west side of the Bering Strait, and even have closer to normal there at the east end of St. Lawrence Island. But all in all, the picture remains the same, very warm for this time of year. All of this, of course, is having a big impact on our temperatures from Nome International Airport. This is just a plot of the daily temperature departures from normal for this year. And you can see over 70% of days have been warmer than normal, and very few days have been, at least since January, have been too much below normal. The year-to-date average through the 20th running just about 5 degrees above normal. And I should say, wow, that's really a lot above normal. Nome is actually closer to normal than most places. Places like Gamble and Shishmaref, with a much stronger marine climate than Nome, are running about 90% of days this year have been above normal. And that's reflecting their very marine-dominated climates and those very warm sea surface temperatures. So that's where we're at. So now we're going to pull out our crystal ball and what's coming up. Well, the forecaster's most basic tool is what's been happening. And so here is a plot from the UAF Sea Ice Atlas, which has monthly sea ice concentrations going back to 1850. And so this plot, I pulled out the data for south of Nome, about 35 miles south of Nome. And this is the November average sea ice extent. I start this in 1953. Why did I pick that date? Starting in 1953, the Army and the Air Force started flying the Bering Sea to recon the ice edge. That was during the Cold War. Lots of interest in the ice. So starting in 1953, we actually have weekly sea ice analysis. So we have these are pretty confident in this data. The DOD flying the Bering and mapping the ice extent continued into the late 60s when satellite imagery became widely available. And so people use that to draw the ice. And then starting in the late 1970s, we have the daily satellite-derived sea ice. But at the monthly scale, there's no reason to doubt that these values aren't broadly correct. So what do we see over the last 65 years? Well, a few things stand out. One, the Novembers with average sea ice cover of none are all since 2007. There's really Back in the early 80s, there's a couple that are fairly low. Interestingly, some of you will remember, it's not that long ago that we had decent amount of ice. 2012, we had decent amount of ice in November, but recent years have been all lower than anything since before 2007. And there hasn't been any high ice Novembers south of Nome since about 2001. Okay, so let's go west of here. And so here's a plot. This is about halfway between Savunga and Diomede. The ice in the Bering Sea, in the western Norton Sound, can develop as the ice grows out from eastern Norton Sound. In the Bering Strait, this is a much more open ocean environment, and that's kind of dramatic. Every year since 2002, the average ice extent there between Diomede and Savunga is none. Every year. And it didn't used to be that way. It's not that it did occur sometimes, but it was interspersed with comparatively high ice years when the ice came down early. That's not happening at all now. And not even happening a little bit now. That is dramatic. So what's happened in the past, we can use that as a forecast tool. Okay, so based on this, do I have any takers that this November's average sea ice extent there in the south part of the Bering Strait is going to be anything other than 0? No. How about for Nome or south of Nome? Anybody going to go for 40% or higher? 30%? 0? Yeah. All right. I'm going to say, now remember, I spent 30 years as a weather forecaster. And it's being recorded. And it's being recorded. So knowing that, I'm going to say it's probably, most likely, going to be less than 10%. I think. That's right. 30 years, that's good training to make those definitive statements. All right. So I mentioned one of the things that I'm interested in is using what we know is happening with ocean surface temperatures as a forecast tool for the future. So what I've got here, on the vertical axis here, this is the average February-March sea ice extent in the Bering Sea. And along the horizontal axis here is the late summer sea surface temperature. Now, back when I was a young buck forecaster, we didn't really think about what the temperatures were in the Bering Sea for the following winter's ice, because the ice was controlled by what would happen with the atmosphere. If it was going to be stormy, lots of south wind, less ice, lots of north wind, be more ice. It didn't matter what the previous summer, fall sea surface temperatures were. And that's reflected here. The colors here represent the year of occurrence. And for northern Bering Sea sea surface temperatures up to about the July through September average, up to about 8.5 degrees, there's really no correlation. That you can't use that as a predictive tool. But now we're getting more and more very warm, and we see that the sea ice extent is tailing off. That makes sense in that the warmer the water, and we've apparently crossed a threshold there, it takes just that much longer to work that heat out of the system so we can get that ice to form. This year, using this same data set, the average temperature, warmest of record, we're out here. So using my little fit here on the line would say that this February, March would be the third lowest sea ice extent of record. Now, of course, okay, did really well there, but we fit that data. So there's some error bar here. But based on this, it's very unlikely that we would even get average ice extent. Very unlikely to get even average ice extent. And just using this, if this was your only forecast tool, you'd go for the third lowest February, March ice extent coming up. So that'll be interesting to see how that works out. Okay, now, as I mentioned at the start, Weather Service at Climate Prediction Center has this new, it's actually a weekly and then a seasonal sea ice computer model system. It's new. It's been running for about a year, but just in the last, over the summer, the data has been made available so that we can grab it and manipulate it and display it in a way that might be useful to Alaskans. So what we have is, it's actually not one computer model. It's a set of related forecasts that give a range of possibilities. In techies, it's called an ensemble system. All you need to know is it's a set of related models. There's actually 20 of them. And so we can get some idea of what the model thinks is the variability in how the sea ice will play out. Now, both the weekly and the seasonal sea ice model are large scale. They're pan-Arctic. So they're not designed to forecast when the ice is going to form in Gullivan Bay. They're really going to do well. They potentially will do well in the open ocean. They're not going to do, no reason to think they will do well where you have narrow constrictions, where you have land sticking out into the water. So we don't want to get hung up on the fine details. We're looking for the big picture with these models. So the weekly forecast comes out once a week conveniently, and it's forecast out 6 weeks, which is a big, big improvement from anything we've had. Right now, and for decades, the National Weather Service has issued 3 times a week a 5-day outlook. And then once a month, they issue a 1 to 3 month outlook. So this is a big improvement in that beyond 5 days. And I say a big improvement, it's a new tool. Is this any good or not? That's the question that we will be watching. The monthly forecast is updated once a month, and that forecasts out 9 months out into the future. So forecast that came out in September goes all the way through the spring season, actually. And so some of the products that come out of this set of related models are things like, you might expect, like sea ice concentration, but because it's a set of models, you get some measure of the variability in these models, so get some idea of confidence. We can extract when the ice will first show up and when it will melt out, which is, I'm very excited about that. And because it's a set of models, we can use that to get an idea of how confident this model system is that there's going to be ice or not. Why did that do that? That's not supposed to say, it's supposed to say through April 2020. So here's the forecast. This is for November. That was made, this is the most recent monthly run, was made in late September. There's a new run that's being made this week. That data will come out in a couple of weeks. So no surprise, given current ice conditions and sea surface temperatures, basically most of the Chukchi Sea remains open water, 15% or less ice coverage. Notice it is trying to forecast the average from all 20 models. Does have some ice in eastern Norton Sound. Also has some ice in Kotzebue Sound. We'll see how that works out. That might work. This is the forecast through April. This is the forecast for November. Sorry, the header got screwed up. This is the forecast for December. Notice that we still have less than 50% concentration through a large chunk of the Chukchi Sea. Do have 30 to 45% down to about St. Lawrence Island. Higher concentrations now in Norton Sound.
Yeah, this is December. Right?
This is December. Here's January. So now there's some stuff that I don't understand going on here. That's got a very low ice in Norton Sound. What on earth is going on there? Well, it's probably not out of the question in January, given what we've seen the last few years. Like, we can envision how this would happen, but I'm not sure how for the January average that we would get 15 to 30% ice cover in central Norton Sound, but we've got 60% north of Nunivak Island. I can't quite picture the weather patterns that would produce that. On the other hand, that very low ice concentration just west of St. Lawrence Island, we've seen that over the last couple of years with that northward flowing current along the east side of Chukotka there. That's certainly within the realm of what we've seen. February. So this again looks, this looks not dissimilar to things that we've seen. This actually looks not very different from what actually occurred in the spring of 2017 with very low ice on the Russian side, somewhat higher ice concentrations on the Alaska side. But notice that area of less than 50% ice sticking up there from north of Nunivak Island up into southwest Norton Sound. Also note, except for the protected bays, this model set has nowhere south of the Bering Strait averaging more than 75%, so mostly all ice covered. Nowhere south of the Bering Strait. March, and we see, now this looks a lot like what we might expect with low concentrations south of St. Lawrence Island. That's almost normal, but fairly low concentrations. Gulf of Anadyr away from the coast. Higher concentrations now in March in Norton Sound. Again, I'm not sure about that area of higher concentrations southwest of Nunivak Island. I suspect that's going to turn out to be a model artifact. And then getting into the melt season, here's April, and things disintegrating in a hurry, even showing up the typical offshore polynya there off the north slope coast there, and really very low ice now around St. Lawrence Island. Okay, so that's just the concentration. Now, been trying to figure out how to show this. This is the dates of the first sea ice formation. It's the first time that in this model system, the average date of 15% or more. So that's not a lot of ice. That's just the open water, not open water anymore. And so this is the ice that either forms before November 1st, or in this lighter blue color is the first half of November. The darker blue color is the second half of November. And then the the first date of freeze is not December 1st or before, is the ocean blue color there. So the average here, most of the Chukchi Sea remains open. Some nearshore ice forms in Alaska. I think that's probably, I'm pretty sure there's not going to be that much ice, but in the next week off of the Kivalina coast, we're not going to have ice off of the western tip of St. Lawrence Island. Those are, I'm sure, are model artifacts. There's certainly not going to be ice in Bristol Bay, I don't think, in November. But all in all, the picture is exactly what we would expect given the warm ocean temperatures and the lack of ice at the moment. November, not a lot. Okay, now we see stuff happen in December. So now here, the light pink is areas that get their first ice the first half of December. The darker pink, the first ice the second half of December. The whitish colors are areas that already had their first ice. So Norton Sound, most of Norton Sound, first ice is the first half of December. Most of the central Chukchi Sea down through the Bering Strait, freeze up is the second half. The first date, not freeze up, first date with more than 15% ice is the second half of December in this model. Some ice farther south near the Alaska coast as well. Notice there's an area there in the Chukchi Sea that in this model average has not yet frozen up when we get to New Year's. And basically no ice in the open ocean south of St. Lawrence. Okay, here's the ice, the area first ice now in January. So this is basically fills in the areas north of St. Lawrence Island that didn't freeze up for the first time in December. And now we have the ice developing about as far south as St. Matthew Island. Not much going on farther south. So that's January. February. February, this is very interesting. Practically no area gets their first ice in February. That's probably trying to tell us something. That this particular system suggests to me that if the ice isn't expanding in February, that places aren't getting new ice for the first time getting ice, that suggests to me we're looking at a stormy south wind dominated February in this model system. And further support for that is, oh, now we get to March and you get a whole bunch, now much more expansion, much more places, many more places get ice for the first time in March. This suggests after a stormy February, maybe we get more north winds in March. See how that works out. I'm pretty sure that this ice is too far south. I'd be surprised if we got ice that far south. But again, looking at the big picture. So, because this is a set of 20 models, we get some indication of range. So what I just showed you, those month by month, were the average. But we can use the fact that we've got 20 different but related models to get some idea of what it would be like if conditions aren't in the middle. What if it actually winds up being colder than the average? So this would be from the models. This is not the earliest freeze up. Technically, this is one standard deviation earlier than the mean date. And so here we have most of the central Chukchi Sea freezing up in the first half of January. We've got ice in most of Norton Sound now. The second half of November, we've got some ice now even south of St. Lawrence Island in late December. So if we want ice, this might be this isn't the best possible or the best forecast scenario, but this would be the earliest plausible development of ice. So that looks okay. Well, what if it's not the best plausible? What if it's the worst plausible? This is extremely scary. Again, this is not the latest that the models have ice. This is the one standard deviation. So this is a not implausible from this model system when the ice would form. So we're now past New Year's and we've got huge area in the Chukchi Sea without that has not yet had 15% ice. A large area here north of St. Lawrence Island, all the way up to 70 north, where the first date with 15% ice is after the middle of January. No year in history has been like that. Even the latest freeze up, 2017 in the Chukchi Sea was 95% snow, 95% ice covered by New Year's Eve. We've never had a year look like this. and I hope that we don't. The late solution here would be freeze up in Norton Sound is the second half of December. Notice that along the southern edge here, this looks almost exactly like the average. There's not much variability in the models there. It's either going to happen in March or it isn't going to happen. Okay, so now I mentioned, because this is a set of 20 different but related models, we can use that to get some idea of the confidence in the model output. So here, the marine blue or the brown indicates that either A, none of the models have sea ice. That's nice to see that in the Gulf of Alaska, there's no ice. And in the north here for December, we have all the models have at least 15% ice cover. In between is where the models differ. The blue shades are some of the models, but less than half have ice. The brown shades are most of the models, but not all have ice. So December, you can see generally most of the models do have ice. Again, there's stuff here I don't understand and I don't think is real. For instance, that area from about Kivalina down to near Shishmaref, why the majority of these models don't have 15% ice cover for December, I don't know. That's probably not unreasonable, but I expect it to be farther offshore. So I think that is not right. I don't know what's going on there. Southeast Norton Sound. I can't quite think of the weather pattern that would produce most of the models not having ice, Unacleat land, but nearly all the models have ice at Nunivak Island. So again, I think those are model artifacts. I won't run through all of these. Here's the January and March. Again, there's a lot of interesting stuff going on here, but I don't have that much confidence in this. Like, why in January do most models not have ice? In Norton Sound, we already talked about that. That again, I think is plausible, but how do you get all that ice, or the models have that ice, all the models have ice near Nunivak. I'm not sure about that. March looks maybe more reasonable with Norton Sound. All the models have ice, but less than half have ice south of St. Lawrence Island there. That could be, I don't think we'd see that much residual ice in the Southeast Bering if that were to play out. And lastly, and we have, of course, the Climate Prediction Center traditional forecast, what the Weather Service has forecasted for climate for decades now. So here's the outlook for November. This was released 10 days ago or so. And so for Western Alaska, November, with the lack of sea ice, with the very warm sea surface temperatures, very high probabilities of significantly warmer than normal and almost no chance of significantly colder than normal for the Nome westward on the Seward Peninsula and most of the western North Slope. Precipitation is on your right. And so here we have basically all of Alaska, increased chances for significantly more precipitation than normal. For Western Alaska, it's not much of a tilt, 37% chance for significantly above normal. If that's a reliable forecast, that means there's a 63% chance that precipitation would be near to significantly below normal. But of the three categories, significantly above normal is the most likely. That's just for November. The early winter season, November through January, really not much change. Temperature forecast tilts very strongly warm. This is entirely being driven by sea ice, or the lack thereof, by the not just that one model system, but all the tools. And precipitation now, a little stronger tilt towards more precipitation. 45% chance, roughly, for Western Alaska of significantly above normal precipitation. That still leaves 55% chance for near to below. But most favored category by far is for significantly above, and that's about twice as likely as the significantly below category. And then for the midwinter season, no change. Tilt's pretty warm. The odds are not quite as high as the early season. More uncertainty in what that sea ice is going to do. Probably not that much uncertainty in what the ocean temperatures will be south of the ice edge, or almost surely be above normal. Still a wet tilt to the precipitation outlook for midwinter. So that's kind of the spatial view. One of the things, because these are probabilistic forecasts, so we forecast all three categories, people sometimes have a hard time wrapping their mind around that, especially if you're not used to looking at this. So what I thought I would do for GNOME, last slide, so I would turn this into, of course, a graph, right? That's what I do. So, so the triangles here represent the range from those maps that we just looked at, plus some additional ones. The triangles represent the 50% bound of where the average temperature would turn out. The red dots are what actually happened last year. When I first made this map, I also put on what the normal is, and I decided to take it off because every single season it basically fell on top of the lower triangle. So that at almost every season, the current forecast is only about a 25% chance that temperatures would even be as low as normal, and much higher chances that they would basically a 75% chance of above normal for these seasons for GNOME proper. So that's the totality of what I have for you. Just to sum it up, what's coming up? Sea ice is got to be late. There's no possibility it could be anything else now. It's going to be thin. Just because it's forming so late, there isn't going to be time for that to age and thicken up. Odds favor warm, odds favor wet. Not strongly, but don't sell your snow shovel on eBay. Storminess, completely uncertain. That's what we really want to know. Models have no skill at forecasting that. But what we know is, one, sea surface temperatures are warm. Sea ice is going to be low. Any storm that comes along, whether it's part of a stormy pattern or not, is going to have extra moisture to pick up from the open water, the warm water, compared to the historical normal. And because whatever ice we have is going to be thin, it's not going to take an episode like we had last winter with 15 storms in 6 weeks. We get 10 days of stormy weather. We could see lots of ice loss in the Bering Sea because it's so thin. So that's what I know on the outlook. And now to the shameless plug part of the program. Some of you have already picked up our Alaska's Changing Environment publication. There's a few copies left in the back at UAF at the International Arctic Research Center. We came out with this right around Labor Day. Gives an overview of what's happened around the state, including things that haven't changed very much yet. So this is also online. If you prefer a non-paper copy, you can get the PDF online. There's also a website that you can just scroll through this. So feel free to help yourself, and thanks for your attention.
Thanks for cheering us up, Rick.
You bet. That's why I put on this shirt. Color and a climate statement. Yes, sir.
For those 20 models, were they weighted equally? Or?
Yes. Everyone counts the same.
Do you think in the future, as you see how they turn out, whether you'll change the weighting? One's more accurate?
That's an interesting idea. In general, it turns out that weighting the models by skill often winds up producing worse forecasts because what happened to work well this year or over the last few years may not work well next year. And so that kind of work has been done, and in general, you don't get anything out of it, or it even makes the forecast work.
Last year when you were here, it resonated with me when you were saying, we have fallen off the cliff. I think that was last year,
It was in July.
in July. And so far, it looks like you were correct. Do you see us, I mean, do you see anything in all that says otherwise?
No.
Because we are having, you know, as everyone probably recognizes who lives here, we're having tremendous ecological pressure put on the ecosystem and our coastal communities. So it's
With this kind of distribution, we're in that positive feedback loop. Late ice begets thin ice, which begets early melt, which begets early heating of the water directly by the sun. Could this change? Yes. If we could get 2 or 3 months of sustained north wind to keep the ice in place longer in the spring, that could, in the short term, help turn things around. The problem is we're not going to get that every year. With the loss of multi-year ice in the high Arctic, we're primed for this kind of thing because this is all first-year ice. And so much more susceptible to loss of that than back in the day when north of 75, everything was multi-year ice. Now, in the Alaskan waters, nothing is multi-year ice. Except for, I mean, once, okay, like last year we had some icebergs float, they weren't icebergs. They were multi-year flows, very tiny, and they all got obliterated in the melt.
With more open water, I assume we're creating more vertical convection.
Yep.
We're more likely to have Arctic cyclones? Is that possible?
Absolutely. You've got all that heat and all that moisture coming off of the open ocean instead of ice with snow on top. And so when the atmosphere is in a configuration to tap into that, oof, much more likely to happen.
40 mile an hour cyclone.
Right.
In the CDC and the state of run thermistors in the Salmon Lake and looked at the lake used to stratify, typically stratifies. And then this year there was a couple of big storms in July that rolled the lake over midsummer, which was really different. And so like Glacial Lake does that frequently, and it's only 17 meters deep, but the Salmon Lake's 40 something, 42 meters deep. So that's the implications on the heated the whole water column. So there was a nice layer of cold water on.
Right.
It probably affects plankton productivity and other things, but you know, we're all sitting and holding our breath wondering what that means.
And so same process writ large is happening in the Bering Sea, and now certainly happening on the continental shelf portion of the Chukchi Sea.
So the ice cover used to keep the ocean from rolling over, but more in the last, since the late 80s, seeing North and South being more salty and more mixed than it used to be.
So one interesting point I forgot to make here. So this is now. In the Bering Sea, last 2 years, our stormy periods are certainly a factor in the sea ice collapse. Up in here, it's been at about as an average October as you could possibly have as far as storminess goes. Winds are almost exactly normal near the ice edge. that's a sure sign. What's keeping the ice from growing has nothing to do with storminess. It's all about the hot ocean.
Last week they had a thing on Discovery Channel about who was NOAA scientist down in over in Iceland. He had DC-3. He's going around checking on these glaciers, and they're now melting faster. Glaciers are melting faster than the snow is replenishing it, and they're dropping sound buoys all over the place. Temperature. And he said that they've got hot water coming, and they're not sure from where yet. But it's going underneath and eating everything out from underneath and upwelling and chopping it up from the bottom.
In Iceland, with all the volcanoes, you've got probably lots of underground hot water to do that.
Well, they say it's coming from a lot further away.
Oh, this wasn't on the Greenland or the Iceland glaciers. This was in the ocean?
It was in the ocean.
Oh, okay.
Yeah, coming up, and they're calving at a much more alarming rate. With those sauna boys, it's hot all the way down.
Right.
Hot water.
Yep.
Hot for there. Anyway.
Above freezing, warmer than it used to be.
So it would probably be safe to say, given that that is where we are right now, and you're saying it's growing so slowly, that we, even if the ice comes to us, it won't leave the cold water enough to keep any kind of barrier again. Ecologically, those southern fish will continue to persist or survive.
That's sure what it looks like. Yes, we get a cold December. Ice could grow out from eastern Norton Sound to here. That's entirely possible. But you can't get significant ice down through the Bering Strait and into St. Lawrence Island and south until the Chukchi Sea freezes up. Doesn't matter what the atmosphere does. You got strong cold north winds blowing over this water, which if it's water, it has to be 28 degrees Fahrenheit or warmer. Otherwise, it's not water, it's ice. No matter what the temperature of the air starting out is blowing over this water, it's going to warm up.
What's the distance again from Utqiagvik to where the leading edge is?
It's just about 400 miles.
Way to go.
It's a long way to go. And this water here is in the central Chuk, basically from about Point Lay on south, away from the coast, these water temperatures are in the upper 30s to lower 40s. That's weeks, months to cool that off. And we know from some of the research vessels that we're sampling the water column temperature, that this area in here, this warm water extends to great depth. We don't need research ships sampling that. We're seeing it right now by the inability of the ice to expand.
When you get that, can you just remind me, when you get that far north in the 2019, where the ice edge is, so the shelf in front of on the Alaskan Beaufort Sea side of things, there's a little bit of shelf, and then it goes rocketing down deep, like 10,000 feet or so, right? So that ice edge is now over very, very deep water.
Yeah.
Is that contributing to the difficulty in making that ice move to the south, because the swells, let's say you get a wind event from the south, those waves are going to be quite large compared to shallow water?
So that's contributing. The fact it's over deep water is contributing. There's effectively unlimited amount of water to upwell its heat now. It's not like the continental shelf portion where you have a much shallower water column.
Let's keep coming, huh?
Yep.
Is this similar sort of pattern happening over Russia?
Yes. So the Weather Service only goes a little bit into the Russian waters there. The East Siberian Sea here is also at record low ice extent and has been for most of the summer.
They're really building up a huge military presence on it too. Russia, big time icebreakers, airfields. They're planning on being there operating winter walls.
Yeah, I mean, this hasn't changed much. Even over here, I mean, there is new ice forming in the brackish waters behind the barrier islands, but there is nothing out in the salt water yet.